All right, so one model has the Jovian planets forming much further from the sun and migrating inwards. There's even another model that's not talked about right here, where, and in fact, this is an interesting thing. If we look out at other solar systems, the really large planets, the ones that are Jupiter-sized or even bigger than Jupiter-sized, tend to be very close to their stars, which is something we really didn't expect when we started looking at these extrasolar planets. That is, planets outside of the solar system. And so there's been a model to say maybe Jupiter and Saturn and Uranus and Neptune started in the inner part of the solar system, and or at least maybe two of them. There's different computer models to try to figure that out, because we don't have time machines to ever go back and see what exactly happened. All right, and so the what's called the planetary debris is certainly the asteroid belt. Actually, there's more than one, but most of the asteroid material is between Mars and Jupiter, right? Where and the three biggest asteroids are, as we mentioned before, Vesta, Pallas, and Ceres. And they look different. They're different sizes. One thing I should mention, though, as well about the asteroid belt is that it's not the way you see in movies. Like if you watch movies and there's a spaceship going through an asteroid belt, you can see the next asteroid over, and it's not all that far away, and you got to dodge and get out of the way and stuff. That's not at all what our asteroid belt would look like. You wouldn't even be able to see the next asteroid over. I mean, but there is a collection between the orbit of Mars and Jupiter, which is a huge volume of space, where there are literally thousands upon thousands of these asteroids, and most of them are less than 300 kilometers across, but there's a few of them that are more than 300 kilometers. And we think that this formed really because of Jupiter, right? And so Jupiter, the most massive of the planets, of the 8 planets, and Jupiter's gravity tends to keep these. We think, and the model tends to show that this material that accreted through in the early part of the solar system. Basically, it didn't. It couldn't form a planet because of Jupiter's presence. Now, if you were to add up all the matter, all the material that makes up the asteroid belt, it really would be smaller than the planet Mercury. But anyhow. So the fragments are these leftover things from the initial formation of the solar system. And as I said, the asteroid belt tends to be rocky material, and further out from the asteroid belt is where you find the comets. This is showing, from all the data that we have, what happened in the early parts of the solar system. Up through about 1 billion years ago. So, the formation of, the sun, of course, is the first thing that forms, and then you have rocky grains forming, as you can see, less than 1 million years ago. Or, sorry, 1 million years after, right? Time zero here is the formation of the sun, and then the rest of the solar system begins to form. Like, for example, during this time, we have ejection of icy planetesimals. Planetesimals are just the things that would perhaps eventually form into planets, but they didn't have to. Some of that material goes to forming objects in the Kuiper belt. And even further from the Kuiper belt is this it's not. There's this region that we've never actually observed anything in this region. It's a theoretical region called the Oort cloud. The reason that this guy Oort came up with this idea in the 1950s, I think it was, is to explain the angle that we see comets coming into the inner part of the solar system. We see the comets coming in at all sorts of crazy angles, and Oort proposed that there was this region outside of, well, they didn't even know about the Kuiper Belt back then, but that there's this region, maybe, well, we actually don't know how far out it goes, but this region well beyond, let's say, the orbit of Pluto, called the Oort cloud, where the comets form. Right, and you can see that there was this huge time where this is forming up to about a billion years after the formation of the solar system. All right, so the Jovian planets and planetary debris. So icy planetesimals far from the sun are ejected into the distant orbits by gravitational interactions with the Jovian planets. That is mainly Jupiter, but of course Uranus, Neptune, and certainly Saturn had something to say about these gravitational interactions, and we think that this stuff, these icy planetesimals, form the Kuiper Belt, and then even further from that, this thing called the Oort cloud. And the Oort cloud actually is a spherical region surrounding the entire solar system. So the Kuiper Belt is actually still more or less within the plane of the solar system, where you find. I mean, it's not quite. There are objects in the Kuiper Belt that are at pretty good angles, like 16 degrees, 20 degrees, and so forth. But the Oort cloud, there's objects. We think, again, this is a proposed region of the solar system. There are objects in the Oort cloud that are at 90 degrees. And so forth, okay, at all angles with respect to the plane of the solar system. These objects in the Kuiper Belt and certainly in the Oort cloud would have extremely eccentric orbits. That is, very, very elliptical orbits. And comets are like this. A comet, the planets are elliptical, right? They do get closer to the sun and further from the sun, but not by much, compared to the size of their orbit. Whereas comets can, be way, way out here and then come in really close to the sun and then go back way, way out. Tens of astronomical units away, and so let's say more in some cases more than 40 or 50 astronomical units at their extreme. And there's all sorts of differences. There's some comets that are certainly stay within the region of Jupiter and then come in towards the inner part of the solar system. All right, so the Kuiper Belt objects have been detected from Earth. A few are large, like Pluto, and there's some other objects. In fact, there was another object that was found in the early 2000s that at first seemed to be larger than Pluto, but actually since then we've measured and found that this thing, which is now called Eris, is actually smaller than Pluto, but it has its own moon, just like Pluto. Pluto actually has 3 moons, these Kuiper Belt objects, have been detected with telescopes, and Pluto, of course, has been photographed by a spacecraft that went out and made a close encounter with it, and that spacecraft is still out there and investigating other Kuiper Belt objects. So about a third of the Kuiper Belt objects we know of are in these what are called resonance orbits. That is, they spin around their own. So this one, for example, is a 3-to-2 resonance. So all that means is, with respect to Neptune, it'll spin about its own axis 3 times for every 2 times it gets close to Neptune. And there's other like for example, Mercury is in a resonance. I forget what the value of it is, but it'll rotate about its own axis, a certain number of times compared to the number of times that it goes around the sun. All right. All right. That's good. And so now we're at the end of this chapter 6 material. Let's go over some of this very briefly. The solar system consists, of course, of the sun and everything that's in orbit about it. Remember, the sun takes up 99.9% of the mass of the solar system, and of course, it's a star. It generates its own energy through nuclear fusion, right? The conversion of hydrogen into helium. I don't know if I said that before, but that certainly is an important thing. Asteroids tend to be more rocky than icy, although there has been some asteroids that have been found to have a good amount of ice material. For the most part, the asteroids exist between the orbits of Mars and Jupiter. Comets tend to be very icy and much smaller than, very, very small compared to like the larger asteroids. The major planets orbit the sun in the same direction, that is counterclockwise. They also spin about their axes. Most of them spin. Well, if you just take the 8 planets, they all spin counterclockwise, except for Venus, right? Venus rotates in the opposite direction about its own axis. It's still going around the sun in the same direction, but it's spinning around on its axis. It's as though Venus has been flipped upside down somehow. Perhaps there was a gigantic collision that happened in the early part of the solar system. Some people have looked at that as a possibility. There's computer models that we use to try to figure that out. Planetary orbits line up more or less in a plane. There's the 4 terrestrial worlds, tend to be smaller and greater density. The outer worlds, also known as the Jovian worlds, tend to be gaseous and very large. The nebula theory of the solar system says that we have this cloud of gas and dust, and it collapses due to its own gravitation. Speculation is that there's some passing star or stars that gets this thing spinning more or less in the same direction. And the condensation theory says that the grains act as condensation, kind of like how water gas condenses to form rain, right? To form liquid water. But this is out in space, right? All right, and then the solar system is relatively orderly. There's not a lot of randomness, and of course the formation theory explains that. Condensation theory is currently the favorite, where the large cloud of interstellar gas, collapses, and then you have these dust particles that accrete to form the planets. The rocky planets form close to the sun. The Jovian worlds perhaps formed further from the sun, although there's some models that predict maybe that's not it. The asteroids never condense into a large object, and of course there was lots of collisions that caused some of those. The leftover planetesimals are ejected from the main part of the solar system due to collisions and various gravitational interactions with the large planet, with the large gas giants to form the Oort cloud. And of course, some of those occasionally get disturbed gravitationally and get flung in gravitationally to the inner part of the solar system, and they are seen as comets. All right, so that is our Chapter 6.